This is the notes for 4.1 sample space. It says a sample space consists of all possible outcomes of an experiment. So there's two organized ways. We can either make a tree diagram or a Punnett square. Okay, so let's start with our first example. As for breakfast one day, you can choose from the following choices: oatmeal, cornflakes, scrambled eggs. With your breakfast, you could then choose milk, orange juice, or apple juice, or hot chocolate. How many possible combinations or outcomes of food and drink are possible? So my area model is what a lot of us think as lattice when you're multiplying. So I'm going to make a list of, I had three options. I had oatmeal, cornflakes, or scrambled eggs. So I had oatmeal, cornflakes, or scrambled. We'll just do E for eggs. So this is my O, C, E for eggs. Then I'm going to multiply that by, I had options for milk, orange juice, apple juice, or hot chocolate. Okay, so this time there's 4. I could do milk, orange juice, so I'm going to say O again for orange juice, apple juice, or H for hot chocolate. So my possible combinations could be, I chose oatmeal and then milk. I chose cornflakes with milk, or I chose eggs with milk to drink. I chose oatmeal with, my second O is orange juice. I chose cornflakes with orange juice, or I chose eggs with orange juice. I then could either choose oatmeal and then apple juice, cornflakes, apple juice, eggs, apple juice. Last one, hot chocolate with oatmeal. No, it sounds a little gross, but yes, it's a possibility. Oatmeal, hot chocolate, cornflakes, hot chocolate, or most likely, probably eggs with hot chocolate. Okay, but all of those are possible combinations. Okay, so if they asked you to make a list, this is one way to keep it a little more organized instead of just thinking the first thing that pops to your head. So instead of writing down, maybe I like oatmeal and then apple juice, and my table mate liked cornflakes with milk. And then the next person I asked was eggs with orange juice, right? I want to be strategic about this so I don't miss any of those possible outcomes. So one way is to do an area model similar to lattice, where I have a list on both sides of each option. So oatmeal, milk, cornflakes, milk, eggs, milk. Okay. My tree is the other option that you've probably seen before when you're looking at probability. Okay, so if I'm starting with my oatmeal, cornflakes, eggs, from there, each one had 4 possible outcomes: milk, orange juice, apple juice, hot chocolate. Milk, orange juice, apple juice, hot chocolate. Milk, orange juice, apple juice, hot chocolate. Okay. Either way, I should have 12 possible outcomes. Okay, so whichever way you like to do it, that's totally your opinion. Okay, if they asked you to make a list, I don't have to write out oatmeal with apple juice, oatmeal with hot chocolate. You can simply give it an abbreviation, and this is a more efficient way to make your list, whichever way makes more sense to you. Okay, you'll notice though the tree diagram is going to get very big very fast, so you're going to want to make sure you have a lot of paper and that you have room to spread out your options. Okay. All right, so let's look at our second one. I'll zoom out a little bit in case you're still writing the first one. If I was tossing 2 coins, what are the possible outcomes? So for my first choice, I could have heads or tails, and then I could have heads or tails. In science, they called this the Punnett square, right? I could have the mom and the dad, mom and the dad. So as I make this coins, I could go heads with heads, or I could go to heads and then tails, or I could do the opposite, so I could get tails first and then heads, or tails and then tails. So notice these are 2 different options. I get heads first and then tails, or tails first and then heads. Okay. If I do my tree, I have heads and tails. The next time I flip it, heads with tails. So this time I only have 4 possible outcomes. Okay, a little simpler. Again, whichever way makes more sense to you, you can go with that. Just make sure if you're doing a tree though that you spread it out if you have a list of more options. All right, so our other option is instead of making a list, if it simply just wants the number of outcomes, I can do what's called the fundamental counting principle. So I multiply the number of outcomes for each separate event. Okay, so I'm gonna go back to over here. I had 3 options for my first choice: oatmeal, cornflakes, scrambled eggs. And then I had 4 choices for drink: milk, orange juice, apple juice, hot chocolate. So 3 times 4, 12. When I was doing my heads or tails, I had 2 options, heads or tails, and then again, 2 options, heads or tails. My shortcut is I can multiply them. Okay, so in our last example, if I was finding the breakfast, that would be 3 outcomes times 4 outcomes. So again, if you just want to copy that in the space, or if you're over here, you're good to go. So I had 3 options: oatmeal, cornflakes, scrambled eggs, times 4 options: milk, orange juice, apple juice, hot chocolate. Total of 12 outcomes. Okay. All right, here's where it gets a little fun though. So this time we're rolling a cube, tossing a coin, and then spinning the spinner in 4 different sections. Okay, so this time there's 3 different events happening. I have a cube, a coin, and then a spinner. Okay, so if you were to try and make a box, would that be possible? Could I do my cube, toss a coin, and then have a 3-dimensional aspect of my box for my spinner? Right? You'd be amazed. I do have some people try that. I'm going to put a big fat X through that. If there's more than 2 events, it's not possible to do the area model, or if you're thinking like Punnett square, right? It's between 2 parents. So I need 2 events, the cube and the coin. There's no way I could factor in that 3rd event of a spinner. Okay, so if I wanted a list, I would have to do my tree diagram. So if I had a cube, I'm looking at 1, 2, 3, 4, 5, 6 sides of the cube. I'm then tossing a coin. So I could have heads or tails, 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 heads or tails. So right there, we're at 12 possible outcomes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. But then my 3rd thing is I'm then spinning a divider that has 4 sections. So 1, 2, 3, 4 from each of these, right? So I'm not going down for all of them, but right here I could flip my cube and get